All right, good evening, guys. I'm trusting that most of you are getting online tonight and watching this video at some point. So tonight we're going to be talking about graphing functions. We've already covered the t-charts and plotting points, and we're going to go into graphing some functions to where we can identify those specific types of functions based on the way their graph looks. There is going to be a fair amount of definitions tonight, and I want you to be prepared for that. So, for example number one, we're going to start, and I'm going to show you how to fill in the t-chart, and then the next slide is where we are going to actually do the graph itself. So, the very first, so when we start with our t-charts, we should remember that this is what we call our input, or our domain, or our x value. All three of those are interchangeable. We're going to add a new definition, which is going to be what we call the dependent variable. Okay, so I'm going to write x in here. And for the second column, we should know, if you guys remember from the notes from this weekend, that the second column is our y variable, or we could also call it our output or our range. Okay, and with the first column being the input and the second column being the output, then we also have what we call, and I apologize, the x is actually not the dependent variable, the x is the independent variable, and the y would be our dependent variable. Okay, and you're going to get to see firsthand how the x is the independent and the y is the dependent. Okay, so we're going to take the graph, the function f of x equals x, and what we're going to do is we're going to fill in this chart. And to fill in the chart, I'm just going to pick easy numbers to put in there. Okay, so I'm going to pick -2, -1, 0, 1, and 2. Those are just totally randomly picked. I could have picked -7, -3, -4, 5, 6, 7. Okay, I could have picked anything I wanted. Now, to figure out the y value, I'm going to plug -2 in for x. So you're going to get f of x. And one thing you guys need to understand is that f of x, it's a way of writing a function. Okay, so it's a function f in terms of x. That's what this represents. Okay, and you guys need to understand that y is interchangeable with f of x. So f of x equals x. This is what I'm going to use. Now in place of x, I'm going to go through and I'm going to plug in each one of these values. So let's start with -2. And that means that y, or f of x, so I'm going to show you, y equals -2. And now we're just going to go down through and we're going to figure out every value for y. So y is dependent upon the value of x. That is why y is the dependent variable and x is the independent variable, because it doesn't matter what x is, it can be anything. But the value of y is determined by the value of x. So for the next one, I'm going to say y equals, and I'm going to plug in -1 for x. So this is -1. And then we have y equals 0. And I'm hoping you guys are noticing a pattern. And this would be 1, and this would be 2. So the pattern here should be that whatever x is, that is also your y value. Okay? So now that I've got this filled out, and this one didn't take much space to do, the rest of them might take a little bit more space. So now I'm going to go in to the next slide, which is, oh, I went actually too far, right here, and I'm just going to rewrite this in. Hopefully you already have this, because you should have it filled out from the last slide. I'm just going to refill it out so you have this information in front of you. -2, -1, 0, 1, and 2. And now I'm going to, see, I have a blank, right now we have a blank coordinate plane. So I'm going to go ahead and I'm going to go in and I am going to put in my coordinate plane. Alright, so let me move the card out of the way here and let me put this in. And you kind of want it somewhere in the middle. It doesn't always have to be. One thing that you guys will hopefully pick up on fairly quickly is the fact that when you're graphing, you always want to set your X and Y axis and your scale. You want to set them to be represented by what the numbers are that you have in the problem. All right, so if I have all positive numbers, I don't need this much negative space over here. I could move my y-axis all the way over. I could move my y-axis all the way over here. Okay, but with this one, you notice that it's kind of right in the middle, basically. So we're gonna go ahead and plot these points now. So the very first one is -2, and it's down 2. So this is my first point right there. The next one is -1 and -1, so that goes right there. 0, 0, and this, in case you forgot, is what we call the origin. And I'm actually going to make these just slightly bigger. Put this up just a little bit more. That'll work. And then the next one is 1 and 1 and 2 and 2. So now I have the points plotted. Now we are going to, this is a line, all right, you can see that it's a line. So now I'm going to connect these points with a line, okay? And something else that this actually brings up another one of our definitions, and this is what we call collinear, okay? And what collinear means is that two or more, so for example, okay, this point here, which is 2, 2, and this one here, 1, 1. These would be called collinear because they lie on the same line, okay? So the last thing left to do is to label the points. And then make sure you got arrows on them because these graphs, this graph particularly, is going to continue on forever, okay? So in a problem like this, you should be able to recognize that the domain, now the domain of the values I have here would be -2 to 2. But the domain of my graph, as you can see, it's going to be all numbers possible because there are no holes and the graph never stops. Same thing with the range. Okay, the range is the y values. According to the table, it would be -2 to 2. But according to the actual graph, it's going to be all real numbers because this is going to continue going down and it's going to continue going up here. Okay, so this is what we call, this is going to be your standard linear equation, f of x equals x. All linear functions and graphs that we deal with will be variations of this line right here. They will be shifts up and down, or the graph might slide side to side, but they're all going to be variations of this graph right here. The next function we're going to deal with is going to be the function f of x equals x squared. We're going to go through the same process we just did. Okay, so this is our x, or our domain, our input, or we also know of it as now the independent variable. This is y, which is going to be our range, our dependent variable, our output, and I think I covered all of them. Anyway, so let's fill it out now. Okay, so again, for the x values, let's just pick really easy, simple x values. So I'm going to do -2, -1, 0, 1, and 2. Now for the y's, we're going to do the same thing. We're going to replace f of x with y, and I'm going to replace x with the value in these boxes. So we're going to start with -2, and I'm going to square it, which means y equals -2 squared is 4. And we're going to do this for every value of x that we had. So now we're going to go -1. -1 squared is 1. Y equals 0 squared. 0 squared is 0. We have y equals 1 squared. 1 squared is going to be 1. And then you have y equals 2 squared. And 2 squared will be 4. So let's fill in the boxes. So we had 4, 1, 0, 1, and 4. I'm going to slide to the next slide, and we're going to fill that chart in again. You guys don't need to. So this is -2, -1, 0, 1, and 2. And the values we got were 4, 1, 0, 1, and 4. Okay, so now we're going to do same type of process that we just did. All right. Now this time, my axes could be different, because you notice right here we're positive, positive, it gets to 0, and then it starts going back up again. All right. So the lower these numbers are here for x, the higher the y value is going to be. The higher the x value is, the higher the y value is going to be. Okay, this is what we call a quadratic function. All right, the first one was a linear function. This is what we call a quadratic function. And in a quadratic function, the graph is going to be what we call a parabola. Okay, so when I set up my my x and y axis this time, I'm going to set it up down here. This is going to give me plenty of space to work with. And we're going to put the x right about here. And you can actually count these out and figure exactly where they need to be. But for the examples, I'm not going to worry about it. Okay? So these are my x and y axis now. All right? It's the same idea. Everything's just kind of shifted down. All right? So now we're going to go ahead and we're going to plot our points. So we have -2, 1, 2, 3, 4. We have -1 and 1. And we have 0 and 0. 1 and 1. And 2 and 4. Okay? So now you kind of see, and if we wanted to check another one and we wanted to do 3 and -3, you would find out that this is actually going to be 3 and 9. 7, 8, 9. And -3 and 9 also. Now we didn't do these ones, but you could do them and you would get the same values. Okay? So now we are going to graph. And these types of graphs, you can't make the lines straight because they're not supposed to be straight. So they're just going to be roughly. All right? So now I'm going to label my points. This is 2 and 4. This is 1 and 1. This one is -1 and 1, and this one is -2 and 4. Okay? So this is what we call a parabola. And again, just like the linear equation, this is our standard parabola. All of the parabolas we do, the width of the parabola inside, this will get wider, or it'll get squished together, or the parabola will shift up, or it will shift down. Okay? All the variations of parabolas will do this. There is also where the graph could flip over to where right now it kind of looks like a U. At some points the parabola could flip upside down and be more like an N. Okay, so that's our parabola. Now let's go over here and we're going to do the next one, which is going to be our cubed function. Okay, and the graph of the cubed function is going to look different as well. Okay, so again, this is our x and this is our y. And let's just pick these odd numbers again. So -2, -1, 0, 1, and 2. And let's plug them in. All right, so we have y equals -2 to the third power. Y equals, well, 2 to the third power would be, this would be the same thing as -2 times -2 times -2, which means y equals -2 and -2 is +4, and +4 times -2 is -8. Okay, so this is going to be -8. Then we have y equals -1 to the third. Y equals -1 to the third power. 1 to any power is always 1. So negative 1, if the exponent is even, means this is going to be positive 1. If the exponent is odd, then this will be negative 1. 0 to any power is still 0. 1 to the third power is going to be 1. And 2 to the third power will be 8. Okay, so I'm going to go ahead and flip to the next page, and I'm going to fill this out. So this was negative 8, 1, 0, negative 1, 0, 1, and 8. 2, 1, 0, negative 1, and negative 2. Again, this time you notice that I have just as much going up as I do down. So I want to have my axes in the middle this time. Okay, so let's go ahead and roughly in the middle. This is pretty close. And now we want roughly in the middle going horizontal for the x. Now we're going to draw our arrows. Okay, and this is what we call a cubed function because it's raised to the third power. So if you think of a triangle, you think of a cube. It's three-dimensional. Okay, that's why it's called a cube. All right, so let's go ahead and we're going to graph our points now. We have negative 2 and negative 8. So 1, 2, 3, 4, 5, 6, 7, 8. We have negative 1 and negative 1. We have 1 and 1. And we have 2 and 8. So it's 1, 2, 3, 4, 5, 6, 7, 8. Okay, and you can kind of see this function. It's not a line. It's not linear. And it's not a parabola, which means it's not quadratic. So you should be able to recognize that this function here is going to look something like this. Okay? It's kind of coming down, so it's like part of a parabola this way, how it's arched. Okay, it's like almost like a U shape or part of a circle, and this side's going to do the same thing, but it's going to switch here, so it's going to be going up, and then it's going to switch to where it's opening down. Okay, and this is what we call, oh, and I actually forgot to plot 0, 0 here, which now is done. So this is what we call a cubic function, and again, same with parabolas and linears. Okay, this is the standard cubic function. Everything we deal with when it comes to cubics, they will either be shifts up and down, they can go side to side, and this could also change to where instead of opening this way and coming down, it could come this way here and down. Okay, so these are all going to be translations of a cubic function. Now the last example is going to be what we call a exponential function. Okay, and this is where you deal with a lot of statistics type material. So with an exponential function, we notice that the variable is actually in the exponent instead of the base. Okay, 2 is our base, and the exponent is where our variable is. Okay, so it's still going to be the same idea. X is still going to be our independent variable, and y will be our dependent variable. We're still going to pick numbers here for x. Now, we're not going to want to pick negative numbers because with exponents, if you raise a power, okay, first of all, you can't ever raise something to a negative exponent. So we're going to have what it's going to be is when you have a negative exponent, okay, it's going to be like, for example, negative 2 would be the same thing as 2 to the 1/2. All right, so if it was 2 to the negative 2, that's going to be the same thing as 2 to the 1/2. And so that's not what we're going to be looking for here. But if we put 0 in, okay, and let's say 1 and 2, 3, 4, we're going to notice the difference in our graph and the way the graph goes, and we're going to notice how it goes up a lot faster than any of the other ones. So 2 to the 0, this is going to bring up a very important rule that you have to remember when it comes to exponential functions. Any number raised to the 0 power is not 0, it's always 1. Then you do 2 to the first is 2, 2 to the second would be 4, 2 to the third would be 8, and 2 to the fourth would be 16. Okay, so we're going to go ahead and we're going to graph this just like we did the last one. So, and I actually forgot to write these in. So this would be 2 to the 0, which is 1. And then y equals 2 to the first, which is 2. Y equals 2 to the second, which is 4. Y equals 2 to the third, and that's 8. And y equals 2 to the fourth, and that is 16. Okay, so let's go ahead. I'm going to fill these in again. So this is 1, 2, 4, 8, and 16. And this was 0, 1, 2, 3, 4. Okay, so let's go ahead and again, you notice that this is 0 and 1. Okay. So we are going to go ahead and do our x and y axis. And while we're doing this, I actually did make a small mistake here. There can be negative exponents, but you'll learn in our exponent rules that if it's a negative exponent, you're going to put it underneath. And I'll show you that real quick. So 2 to the negative second power. The exponent rules teaches you to take this and put it underneath the fraction line. So this would be the same thing as 1 over 2 to the second power, which is going to be 1 over 4. Okay, so I'll actually put one more in here just so you can see it. So this would be negative 2 for the exponent, and this would be 1/4. Okay, and if you use your calculator, and you do 2 to the negative third, and 2 to the negative fourth, and 2 to the negative fifth, these numbers here are going to constantly get smaller, but they're never going to equal 0. So what we're going to do is I'm going to draw my coordinates. So I'm going to put my coordinates here because I know that this is never going to go below y equals 0. And put this one in the middle again. Let's go ahead and draw this. Okay, and let's go ahead and we're going to use negative 2. It's just going to be harder to do because of where it's located. Okay, so negative 2 is going to be right about there. It's going to be kind of hard to do. We have 0 is 1. We have 1 is 2. 2 is 4. 3 is 8. That's 1, that's 4, 5, 6, 7, 8. And 4 is 16. So that's 9, 10, 11, 12, 13, 14, 15, 16. Okay? And now we're going to go ahead and you're connecting the dots just like we did on the other ones. Okay? So this time, this is going to come down just like this, and this is going to continue, but it's never going to actually touch 0. Alright? Because anything raised to an exponent will never equal 0. Alright? So this is what your exponential function will look like, and this will continue. Now this is going to bring up another one of our definitions, and then I'm going to switch to that page. Okay? This is our base exponential function. All just like all the other ones, there are variations of this where it'll slide left or right, or it may go up as well. Okay, so or it could even go down. This is going to bring up our last main definition, which is going to be an asymptote. And what an asymptote is, it's a value that for that function you will never get, that value will never be attainable. So for example, in this problem, as I told you, this is going to continue to go down, but it's never going to touch 0 because 0 is an asymptote, okay? The range for this graph is going to be y is greater than 0 because y can be any value except for 0 and below. So it's only going to be bigger than 0. And that's because these are what we call asymptotes. All right. So that'll be another one of your definitions. Let me pull up the definition page. So we had linear, which dealt with the linear function. We had quadratic, which dealt with our quadratic function. Something else I did not touch on is an x-intercept and a y-intercept, and I'll show you that real quick. So the y-intercept is where this graph here, this point right here, would be what we call the y-intercept. Okay? And let me actually go to one of the other ones. This point right here would be a y-intercept, and it would also be an x-intercept as well. And you'll need to look up the definition for those so you understand that a little better. You'll also need to look up the definition for asymptote, which we just talked about, and as well collinear, which was something that we talked about a little bit ago with the linear equations. Okay, these definitions are up here. You should be able to copy them down, and actually I forgot to write two other ones down. One of them was dependent and say dependent variable, and then independent variable. And you'll need to write these two down as well as part of your definitions. I hope you guys have a great night, and we will talk to you guys tomorrow. Come prepared, ready for class.